Connected home devices, such as smart appliances and security systems, are projected to grow their market share significantly to reach $490 billion in 2019. But many smart technologies today lack connections to mainstream consumer benefits, such as energy savings and a more efficient and reliable power grid. To address this gap, Pacific Northwest National Laboratory issued a challenge to tech innovators to advance the connectivity of buildings through solutions of their own. And 12 weeks later, they demonstrated their solutions at Seattle's Smart Building Center. The event kicked off with an introduction by PNNL's Nora Wong, followed by project pitches from the 5 competing teams to a panel of judges in a diverse audience of nearly 100. We then heard from Amazon, Microsoft, and PNNL on exciting new developments with the Internet of Things and connected buildings research.
So the building community has been setting up goals like net zero buildings and carbon neutral, meaning zero greenhouse gas emission and overall sustainability. In the meantime, technologies have been fundamentally changed the way we live, work, and play. So how will this affect our buildings where we spend 90% of our time?
So here's the name of our startup called Enerfen. So it's kind of like the energy Fitbit for your home. So basically, it's kind of like you live with energy auditor. So he will be there at your home all the time to help you save energy and enable demand response. It will be available for free. So now it's available. It will be available in Thailand soon. So basically, we if you have Enerfen, it will help you save up to 30% less.
What we're trying to do with our project is flatten electricity demand by coordinating when air conditioners come on in residential buildings. And so, rather than trying to optimize air conditioning within a single household, what we're trying to do with this project is how can we coordinate air conditioners of several households or maybe a neighborhood so that they're coordinated to come on at different intervals that reduce electricity demand and somewhat reduce electricity consumption.
First of all, our minimum viable product is going to be to provide our engineers a way to look at the building automation system data and identify energy conservation measures much more quickly, where we'd like to build interfaces for the user to select the BACnet points that they want to analyze, rename them to more appropriate names, and also to provide the ability to visualize the data to get meaningful insights into the building operation.
By doing building retuning, we were able to identify low-cost or no-cost opportunity for operators to improve their buildings. And thinking the case that if you're a building operator, if you're a building owner, that you have 2 buildings, that you can give the data to Voltron, I can push the data to Amazon Cloud. I have the Amazon Cloud to do the analysis, and I can present this chart to you. That I'll be telling you that your building is not operating very well.
Ventus Scheduler is an application based on Voltron that is going to reduce the energy consumption of your building. We are going to adjust the operation of your equipment according to dynamic occupation. Most of the building automation systems, they are operating with fixed values, with fixed settings, with fixed schedules. But also, because we are providing an airflow for the maximum occupancy, when there are less occupants, we are overcooling the environment. So Ventus is going to adjust your equipment to your real occupation.
So, no, I really think this is a special place, and I think that we have recognized, the good work of this area, your way of thinking, your embrace of transactive control, your embrace of Voltron, your embrace of looking at the combination of energy and IT to unlock a whole new opportunity stream, right? A whole new value stream, a whole new engagement, customer benefit, consumer benefits from that integration of energy and information that